Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and very important concepts for our upcoming CSIR NET and the GATE Physics exam. So I hope that the discussion which we will be doing today in the session will be getting clear to all of you guys, and we are going to continue the discussion in the session just in some time. Let me just show you some important slides first of all, and after that we will continue the discussion. So basically, if I'm going to talk about the session today, we will be taking the most important questions and the concepts of quantum mechanics in this session. Okay. And guys, one more thing, that here we are having a subscription going an offer going on Unacademy subscription, which is valid just till 28th. Okay, February. So in that case, if you don't want to miss it and if you want to grab this offer, you can take the subscription before 28th February so that you will not miss it and you will be able to get the discount in the total subscription amount. One more thing guys, you have to use and apply the referral code that's Anjali Live as mentioned here on the screen to grab this offer. Also, if I'm going to talk about the other important things here, that's going to be in upcoming days, so many new courses by the top educators will be starting on Unacademy, which will be helping you a lot to take your preparation to the next level and to do the best preparation for your upcoming exam. So this is how everything will be helping you and you can do the best preparation. Okay. All the details about the offer have been shown here on the screen. So if you don't want to miss it, you can go ahead and take the subscription. This slide is going to be about the iconic subscription guys. So if anybody will be proceeding further to take the iconic subscription, they will be able to get all these benefits. Even now the notes are available on the learning app, which will be helping you to take your preparation to a next level under the guidance of top educators and with all the important things which have been shown here on the slide. You just have to use and apply the referral code Anjali Live to grab this offer, and the offer which is going on right now. This is going to be the slide regarding the plus subscription, and all the benefits have been shown here which you will get if you will take the plus subscription. Along with that, the referral code has been mentioned, and this is about the light subscription. You can even use and apply the referral code Anjali Live whenever you will be taking the light subscription. This is about the difference between the different subscriptions. So whichever you find more beneficial for you, you can take that subscription and start your preparation under the guidance of top educators. Even you can let your friends know about this offer so that they will not miss it and they will be able to grab this offer too. Here are a few more important slides, like this is going to be the largest learning platform we are going to have. Along with that, something regarding the session, some of the details about me. This is about the community feature we are having on Unacademy, which will be helping you to know about the latest updates and important information you can easily get with this feature. Okay, now let's go ahead and let's start the discussion about the questions and the concepts we will consider in the session today. So guys, if I'm going to talk about today's session, I'll be taking different concepts based questions from the quantum mechanics part. So if you're the one who is afraid of working on the quantum mechanics questions and to work on the concepts from this section, or if you are not that much confident about solving the questions of quantum mechanics, then in that case you can take or attend this session, which will be helping you a lot to take your preparation to a very good level. So let me just start giving you the questions now. Okay, and you can have a look at this, that how everything will be helping you. Just a second. Let me just give you the first question and different concepts based questions then. And all these questions are the one you can expect in your upcoming exam, from which section the questions can be there, like all that is what we will consider. Let me just write the first one and let's see how many of you will be getting it correct. So a particle of mass m is confined in the potential that's going to be Vx is equal to half m omega square x square infinity. And in this case, if we will talk about the first condition, that is only applicable for x greater than 0, and for x less than equal to 0 we are going to have the infinity value for the potential. Let the wave function of the particle be given by, that's going to be psi x is equal to minus 1 upon root 5 psi naught plus 2 upon root 5 psi 1, where psi naught and psi 1 are the eigenfunctions of the ground state and the first excited state respectively. The expectation value of the energy is. Options are 31 by 10 h cut omega. Next one is 25 by 10 h cut omega. And next one is 13 by 10 h cut omega. And next one is 11 by 10 h cut omega. You can try working on this part and let me know once you will get it done that what will be the right answer according to you guys. And wherever you will have any doubt, you can just mention it, we can talk about that. But if it will be clear, then that's great. So I'll wait for your reply for some time, and after that I will be just continuing the discussion. A particle of mass m is confined in the potential Vx is equal to half m omega square x square and infinity for different range. It has been shown. Let the wave function of the particle be given by psi x is equal to minus 1 upon root 5 psi naught plus 2 upon root 5 psi 1, where psi naught and psi 1 are the eigenfunctions of the ground state and the first excited state respectively. So now you have to find the expectation value of the energy. Okay, do it now and let me know when you will get it done. And if there is any doubt anybody will have, just let me know about that too. We will be trying to consider it then. Waiting for your reply, guys. Let me just tell you what you have to do and how you will be working on it. So basically, it has been given a particle of mass m is confined in the potential, which is Vx is equal to half m omega square x square for x greater than 0 and infinity for x less than equal to 0. Okay, so first of all, what is the system given to us here? This is going to be the half harmonic oscillator. So once you get it, oh, it's half harmonic or truncated harmonic oscillator we have. So now you will think about the related formulae, means the energy formula as per the system, what it will be, how you will get the final expression, okay, and all that. Okay, done. And that's how you can like proceed. Done. So try it now and let me know. Otherwise, I'm gonna start solving it now. Okay, what they have asked you to find? See, they have asked you, uh, see, the expectation value of energy. Okay, you have to consider. So that's how you have to move ahead. Now if you are the one like who doesn't know about the energy formula for the truncated or the half harmonic oscillator, so in that case you may have confusion regarding this part, that what should be the next step you have to consider. So let's talk about it. So basically in this case, a particle of mass m is confined in the potential Vx is equal to half m omega square x square for x greater than 0 and infinity for x less than equal to 0. Let the wave function of the particle be given by psi x is equal to this, where psi naught and psi 1 are the eigenfunctions of the ground state and the first excited state. So you have to find the expectation value of energy. What is that? In general, we all know it's going to be summation over n e n p n. Done. So it's going to be E1 P1 plus E2 P2. Done. So in this case, what will happen? It's going to be energy E1 is equal to what? N plus half h squared omega. We will be using that expression of energy. While you can have different forms of energies too, and corresponding n values can be different, but here we will be using that same energy value but different n values. That will be n I will take is odd. For ground state, n is equal to 1. For the first excited state, it will be n is equal to 3. Then for next, it's 5. Then for next, it's 7, like that. So in this case, when you will consider you are having the energy states given to you is psi naught and psi 1. So 0 I will not take for n. I'll take 1 because it is half harmonic oscillator and the formula I'm using is gonna consider the odd n values. So it will be 3 by 2 for n is equal to 1 in n plus half h squared omega. H squared omega into probability. What is that? That's going to be probability of finding the particle in the particular psi naught state. So minus 1 upon root 5, its a square will be 1 upon 5 plus 4 upon 5, that is 5 upon 5, which is going to be 1 in the denominator. So the probability of finding the particle in the ground state will be just 1 upon 5. Okay, this is going to be respective probability plus What about the energy of the next state? That is 1 3. So 3 to the 6 plus 1, 7 upon 2 h cut omega. Done. What will happen next? It's going to be probability P2, which is going to be 2 to the 4 upon 5. So you are going to get this. Now next thing is 3 and 7 fours are 28. 28 plus 3 is 31. 31 upon 10 h cut omega, that's option A. It will be a correct answer. Now you can see if you will be using the incorrect expression or the value or the formula of energy, your answer can get wrong. But if you will relate it with the correct expression, you will get it correct. Now the formula I have used there is for the half or the truncated harmonic oscillator, that is n plus half h cut omega for n is equal to odd, which is 1 3 5 7 so on 2. This is how we consider it for the truncated or the half harmonic oscillator. Let's go ahead. Let me just give you the next question which we will be considering right now, and then we can easily consider it. Let's go ahead with the next question. If in case there is anybody having any doubt, let me know. We can talk about that. Next question is, a particle of mass m is confined in an infinite potential well Vx is equal to 0 infinity 0 if x is lying between 0 to L and infinity otherwise. Next thing is, it is subjected to a perturbing potential Vpx equal to V naught sine 2 pi x by L. Then within the well, next is, let E1 and E2 be corrections to the ground state energy in the first and second order in V naught respectively, which of the following are true? Options are E1 is equal to 0, E2 is less than 0. Next is E1, that is the first order correction, is greater than 0, E2 is equal to 0. Next is E1 is equal to 0, E2 depends on the sign of V naught. E1 is less than 0, E2 is less than 0. Done? You can try it now and let me know as you will get it done. Or otherwise, just in some time, I'm going to talk about it, that what steps you have to take and how you can reach to the final answer for this question. Waiting for your reply for some time and then I'll be continuing the discussion too. Waiting for your reply, guys, and then I will be continuing the discussion about it as well. Okay, guys, let's quickly talk about it. In this question, they have mentioned a particle of mass m is confined in an infinite potential well, for which they have given us the potential expression to Vx is equal to 0 and infinity, 0 for x lying between 0 to L, and infinity otherwise. Next, they have mentioned is it is subjected to a perturbing potential. There is the perturbation applied to the system has been given to us within the well. If let E1 and E2 be corrections to the ground state energy in the first and the second order. Okay, so in that case, what will be the true statement we will have, or the true value of E1 E2 we can consider? That's what we have to find. So if I will talk about the first order correction to energy, how I can consider it actually. So it's going to be E1 1, which is going to be equal to, you know, for this type of system, which is the 1D potential well, you are having the wave function, nth state wave function as root 2 by L. L is the this value, okay, the range, the length, the width, whatever you want to call it. Sine n pi x by L. This is how you will have it. And here n values start from 1. So minimum n value is going to be 1. Done. Next thing. If we will talk about the next part here, that's going to be root 2 by L sine n pi x by L. Now in this case, what will happen? So in this case, you are going to have V naught sine 2 pi x by L. Even they have given you the perturbed or the perturbation applied to the system. So E11 will be integration psi 1 star perturbation applied to the system psi 1 and dx or d2 d top. Okay, so it's going to be 0 to L we will have. So root 2 by L into root 2 by L from psi 1 part will be here. You can initially write it. Integration 0 to L, then you will have V naught as a constant, which is from the perturbation applied to the system part, and sine 2 pi x by L is even there. So sine square pi x by L from the sine 1 star sine 1 star part we will have, and next is sine 2 pi x by L. Then this is what we will have. But when you will observe it, it's going to give you what? The final integration answer you may be getting 0 for this part because it's going to be overall odd function. Okay, and if you will consider sine cube and all, like, even it's gonna give you the same thing there. And if you will integrate it, okay, so what you will have 2 sin x cos x, you can write at place of sine 2 pi x by L. This will give you sine cube and cos, okay. And when you will just integrate, then you will have, see, sine will give you cos dx is equal to dt. So then you will integrate the sine part, it will give you cos. And when you will consider it to be like further simplification here, so you will be getting overall value as 0. Why? Because cos pi and cos 0 value, you know, it's cos pi minus 1, cos 0 1. So they will get simplified. And I think you are finally getting the value to be that's 0 for E1. You can even check it out and let me know if in case there will be any doubt you will have. Once you're gonna get that value to be 0, you will have the choices like E1 is equal to 0 in option A and option C. So directly you can consider that, you know, E2 is going to have this negative value or the 0 value. So out of A and C, you are getting that A is going to be the more appropriate answer, because one statement about the second order correction to energy, we know that it's going to be either negative or 0. So that's how you are getting your option A is the correct answer. If you know about the important points related to the topics, you can directly select the answer. It can be quite simple and easy for you to consider it. If there is any doubt anybody will have, just mention it, I can talk about that. And if everything is clear, that's great. We can go for the next question then. So for second order correction, we just related the idea of second order correction to the energy part. For first order, I have written the expression, you can just simplify it. I think you're gonna get 0, but if no, whatever you will get, then you can select the most appropriate answer associated with it. This is how it will work. I will be giving you the next one now. If in case you will have any doubt in this part or any part we have considered till now, let me know about it. It's going to be your next question. We are taking the questions based on different concepts. So consider a system in the unperturbed state described by the Hamiltonian that's going to be H naught is equal to 1 0 0 1. The system is subjected to a perturbation of the form that's going to be H dash is equal to delta 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 delta, where delta is less than or very much less than 1. The energy eigenvalues of the perturbed system using first order correction or first order perturbation approximation are. Options are 1 and 1 plus 2 delta. Next one is 1 plus delta and 1 minus delta. Next one is 1 plus 2 delta and 1 minus 2 delta. Next one is 1 minus plus delta and 1 minus 2 delta. Let me know as you will get it done. Initially, I'll give you some time to work on this part, and whatever will be right answer according to you, you can just mention it. Other than that, in just some time, I will be continuing the discussion too. And we will talk about it, that what are the steps you have to take. These are all deltas, okay? That is this delta. So all in the H dash matrix. So let me know whatever is going to be your right answer and whatever you have to consider to get the answer for this question. If you know that, start working on it and let me know what will be the right answer according to you. If you will not get it, we will talk about that then. Try, and let me know as you will get it done. Waiting for your reply, and just in some time I'm gonna continue the discussion too. So Hamiltonian H0 is given, which is unperturbed state described by this Hamiltonian, okay? When the perturbation was not applied. Then the system is subjected to a perturbation of the form H dash is equal to delta, 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 like that. Where delta is very much less than 1, the energy eigenvalues of the perturbed system using the first order correction or the perturbation approximation will be what? So actually you can separately find their eigenvalues, because you know energy is the eigenvalue of the Hamiltonian. So since our H0 is going to be a diagonal matrix, because its principal diagonal elements are going to be equal to 1, so we will be getting its eigenvalues to be 1 and 1 for the first matrix. And the next one we are going to have is the H dash. So what are the eigenvalues of H dash we can have? So it's a matrix, you can call it like a kind of where all the rows and the columns are the scalar multiple, because you can see one time each you can write, or all are equal. So in that case its eigenvalues will be traced, that is 2 delta comma 0. So you can make their combination 1 with 2 delta and 1 with 0. So it will give you 1 plus 2 delta and 1 plus 0, that's going to be 1, and 1 plus 2 delta, which is option A, and that will be your right answer. Tell me if in case there is anybody having any doubt, we can talk about it. Otherwise, this is how you can simply find the energy for any such case. Let me know if there is something not clear to you. We can talk about that surely. But if it is clear, that's great. We can go ahead with the next question part. Let me just write the next question now. I'm gonna give you the another one. If you will have any doubt till this point, you can surely let me know about it, and we can consider that part. It is a question which will be helping you to get or to understand a concept too, because it's actually a concept based question. So the question is, the ground state and first excited state wave function of a one-dimensional infinite potential well are psi 1 and psi 2 respectively. When two spin-up electrons are placed in this potential which one of the following with x1 and x2 denoting the position of the two electrons correctly represents the space part of the ground state wave function of the system. Options are 1 upon root 2 psi 1 x1 psi 2 x1 psi 1 x2 psi 2 x2. Option B is 1 upon root 2 psi 1 x1 psi 2 x2 plus psi 1 x2 psi 2 x2. Next is 1 upon root 2 psi 1 x1 psi 2 x1 psi 1 x2 and psi 2 x2. Option D is 1 upon root 2 psi 1 x1 psi 2 x2 minus psi 1 x2 psi 2 x2. Sorry, the last one is 1 and that's it. So you have these options in this given condition. You have to just see which one seems to be correct expression in this case. And what do you think will be the right answer? If you will not get it, I'll talk about it. But if you are gonna get it, you can tell me what will be the right answer according to you. Okay, so let's do it this way. First of all, you will try and then let me know what do you think will be the correct answer. Other than that, I'll be talking about it, that what is the condition and how you can get to know what will be the right answer for you will have for this type of questions. Clear? Let's go ahead. So they are saying the ground state and first excited state wave function of a one-dimensional infinite potential well are psi 1 and psi 2 respectively. When two spin-up electrons are placed in this potential, which of the following with x1 and x2 denoting the position of the two electrons correctly represents the space part of the ground state wave function of the system? That's the question. So remember one thing, for the electrons which are fermions, okay, we are going to have the wave function which is asymmetric or antisymmetric in nature. So when you will consider 1 2 minus 2 1, so actually 1 2 minus 2 1 must be there. So if we will talk about this part, look at this 1 2 psi 1 as a function of x1, psi 2 as a function of x2, then 2 as a function of x1 and 1 as a function of x2. So they have been interchanged and a negative sign is even there. So option D is going to give you the right notation and the right expression here. Okay, this is how we can easily get it, and this is how you will be able to get your final answer. Let me know if there is anything not clear to you or anywhere there is any doubt. We can talk about it, and we will be trying to consider whatever doubt you will have. So let me just give you the next question too. And if there is everything clear, that's great. I'll be writing it. Okay, the next one is a particle just a second, I'm gonna write it. So it's going to be a particle of mass m is subjected to a potential that's going to be Vxy is equal to half m omega square x square plus y square, x lying between minus infinity to plus infinity and y lying between minus infinity to plus infinity, right? So the state with energy for h squared omega is g fold degenerate the value of g is what? That's what you have to find. Clear? So you can try working on this part and let me know what will be the right answer according to you, and let me know about it. Otherwise, we will be talking about this part, that what you have to consider. That's great. You can try. If you are getting the answer, mention it in the comments. Whatever you think will be the correct answer for this question. Otherwise, in just some time, I'm going to explain it to you, that what you have to do and how you will be reaching to the answer. So actually, in this case, if I will talk about the question exactly, they have mentioned a particle of mass m is subjected to a potential which is v as a function of x and y is equal to half m omega square x square plus y square, where x is lying between minus infinity to plus infinity and y is lying between minus infinity to plus infinity. The state with energy, that is 4h squared omega, is g fold degenerate. Okay, the value of g is, so it's 4. Very good, Digvijay. Because we know that in this case, for the 2D isotropic harmonic oscillator, what is the meaning of isotropic harmonic oscillator? It's going to be that omega value is same along x and y axis both, so it is isotropic harmonic oscillator. In this case, we will have the degeneracy which is equal to n plus 1. And also in general, we know that in the energy formula we are having nx plus ny plus half which is 1 h squared omega. So if I will take nx plus ny to be n, it's going to be, that is n h squared omega, n plus 1 h squared omega, sorry. Done. So n plus 1 is the value you will have in the energy case, which is 4. Hence your right answer is going to be 4. That's how you can just simply get it. And this is how you are going to get the final answer. So it's correct. And even if somebody finds it difficult to relate it with this expression or this way, So they can easily find it that what are the possible values of nx, ny they can have, and how many such values are possible. That will be degeneracy. So if I will talk about the first one, it will be 0 comma 3, because if you will take 0 comma 3, it will give you 4. Okay, 3 plus 1. And next is 0 3 comma 0 nx 3 and ny 0. Then 1 comma 2 and 2 comma 1. If you will see, these are the possible values, and since it's the isotropic harmonic oscillator, for harmonic oscillator n values start from 0. So that's how simply you can get it, and you will be getting your answer this way. Let me know if in case there is anybody having any doubt, we can talk about it, and we will be considering that part. But if it is clear, then that's great, and we can go ahead with the next question then. Is it clear to everyone? If there is any doubt, just mention it. We can even talk about that. But if it's clear, we can go ahead. Okay, let's take the next one. Oh. It's here. The question is, a particle is confined to a one-dimensional potential box with the potential that is going to be v as a function of x, that is equal to 0 and infinity, 0 for x lying between 0 to a, and otherwise it's gonna have the value infinity. Then if the particle is subjected to a perturbation within the box, W is equal to beta x, where beta is a small constant, the first order correction to the ground state energy is, options are 0, alpha a beta upon 4, and option C is a beta upon 2, and option D is a beta. That's what you have given to you. Now you have to consider what will be the right answer in this question for you. You will have, and tell me whatever you think will be the correct answer for you. I'm gonna initially wait for your reply, and then we will be continuing the discussion and we will talk about it. What exactly is the right answer? So here is a trick which can help you in any such type of question. Now what is the trick? Let me just tell you that. So basically, whenever you have the potential given to you, okay, like you know about the system and you have the information about what it is representing, what has been mentioned, what has been given. So next thing is, you can easily find the first order correction to the energy if the perturbation applied to the system is a variable perturbation like the beta x is written there. Okay, so in that case, the first order correction to the ground state energy will be equal to the expectation value of the perturbation applied to the system. So which will be what? If you will consider beta and the expectation value of x. So what it will be? Just you can see extreme values of x here, which is 0 and a. So it will be 0 plus a by 2. So it will be beta a by 2, and that's how option C will be the correct one. Otherwise, if you think, no, I don't want to do it this way, so you also know about the wave function expression of this potential expression wave system, that is root 2 by a sine n by x by a, where n values start from 1. So for the ground state, it's 1. For the first excited state, it's 2, like that. So for the ground state, whatever wave function you will have, what you can do, you can simply write integration 0 to a, the region where the perturbation has been applied, psi 1 star, perturbation applied to the system, psi 1 and dx. That's it. You just have to solve this integration. You will also be getting the same answer with that. Otherwise, your option C must be the correct one, and that's how you can easily find it. Clear? If in case there is any doubt, let me know. And I have even told you how you are getting it. So I hope it's clear. But if you will have any question, query, or doubt, just mention it. We can talk about that too. Otherwise, I'm going to give you the next question now. So our next question is, let me just tell you. And even whatever questions we have taken till now, if you will have any doubt or difficulty there, you can mention it. We can talk about that. And if everything will be clear to you, that's great. So here is your next question. Here is your next question. The degeneracy of the third energy level of a three-dimensional isotropic quantum harmonic oscillator is, options are 6, 12, 8 and 10. You can start working on this question, guys, and let me know whatever is going to be the right answer according to you. That's great, Digvijay. Try it now, guys, and let me know about it. What do you think will be the right answer for this one? Initially gonna wait for your reply, and after some time I will be talking about the process and the steps too, to work on any such type of question, and what are the steps you have to take. Everything we will consider then. A, that's great. So they are talking about third energy level. So you know ground first and second. Okay, so in this case, what will happen? It's going to be n plus 1, n plus 2 upon 2. Clear? So for the third energy level, your n value is what? 2. So it's going to be 2. See, if I'll put n is equal to 2, 3 into 4 upon 2. 2 2s are 4, that's 3 2s are 6. It's option A, which is the correct answer we will have, right? Okay, so let's continue to the next one, and this is the formula which I have mentioned. Just a second, guys. Just a second, okay? I'm gonna just talk about the next one. Okay, yeah, right. Digvijay, actually, it's not a kind of group, and we are not supposed to discuss any such thing. Okay, done. Just a second. Okay, now let me just quickly give you the another point here. Okay, the another important question, and then we will be ending this session after that. So let me just give you the next one. And if in case there will be any doubt you will have, you can surely tell me. Okay, it's a general discussion actually. If you have to find the expectation value of R square for the harmonic oscillator, then how you will be working on it and what steps you have to take for that. So I am going to answer it for you, like, or if you know, you can just mention that too. So let me know what you want to consider. Digbijay? So here we are going to have, like, you may have some playlist available, or on Unacademy learning app you can check out my special sessions, okay, or the free live classes part, or that way you can find most of my sessions, or even if you want to join the plus you can join them too. And even guys, as I have told you right now, a latest offer which is going on Unacademy, as per which you can save more, and that is just valid till 28th February. So even if any of your friends were waiting to take the subscription or wants to take the subscription, you can even share this information with them. They just need to use and apply the code that's Anjali Live, as written here on the screen, and by using and by applying the referral code, they will be able to get the discount too. And along with that, up to free 4 months extension will be there. Okay, so that's how you can see all the details about the latest offer have been mentioned here on the screen. Other than that guys, we are having the details about the iconic subscription, that what benefits you will get there. Okay, if you will take the iconic subscription, then for the plus subscription, what are the benefits you will get there. And this is going to be about the light subscription. The difference between the plus iconic and the light subscription have been shown here on the screen. So you can have a look at this part too, and whatever you think will be working better for you, you can go for that subscription. You can take that subscription and start your preparation under the guidance of top educators. Other than this part, the special classes are even there, and the sessions here on Unacademy Live CSIR UGC Net. So depending on whichever you think you will be finding more beneficial for you, you can take that, okay, or subscription and grab this offer too. So this is what I wanted to discuss with you at the end once. And now let's continue to the discussion of one last point. So expectation value of R square for the harmonic oscillator will be n plus half h squared upon m omega. This is the formula. Here n values will start from 0. So depending on for whatever state they have asked you to find it, you can just simply consider that part and you will be able to write that too. So this is how we will have to consider, okay, this thing, and we can simply find it. And same way, if you will be having p square, so you can write n plus half h squared m omega. That's how you can consider this part too. So let me know if there is any doubt anybody is gonna have. We can surely talk about it, but if everything is clear, then that's great guys. Otherwise, we are gonna keep it this much right now. And thank you so much everyone for joining this session. Okay, thank you. Let's keep it this much right now in the session. And if there is any doubt, you can just tell me about it too. Thank you everyone. If you will have any questions, queries, or doubt, you can surely let me know about it. We can talk about that point as well. But if everything is clear, that's great, great, great. And we will be keeping it this much in this session today then. all the important details I've shared with you. Even if you know like any of your friends, those who are waiting to take the subscription and wants to do the best preparation under the guidance of top educators, you can share this information with them as well. Let them know about this important offer and the offer which can help them to save a lot, so that they will not miss it and they will be able to grab it. And anybody who will be proceeding further to take the subscription, because the offer is just valid till 28th February, so you need to use and apply the referral code, that's Anjali A Live, as mentioned here on the screen. By using and by applying this referral code, you will be able to get the discount too. Thank you so much everyone for joining this session and